In the previous segment, we discussed simple exponential smoothing, and we saw that this method is used when there are only random variations in the demand, but those variations are significant and unpredictable. But if the data, apart from random variations, also exhibits some trend, then we make some modification in simple exponential smoothing and use what is called trend adjusted exponential smoothing or adjusted exponential smoothing for short. So adjusted forecast for a next period, that is period t plus 1, is equal to forecast for that period using simple exponential smoothing. So this term comes from using simple exponential smoothing, and we add the trend factor into that to find the adjusted forecast. And how we can find the trend factor? Smoothing constant beta, that is the smoothing constant for trend, in the similar manner as you used alpha, but here the beta is used to assign some weights to the most recent trend. So that is beta into change in forecast in the most recent period. So ft plus 1 minus ft plus 1 minus beta into the value of the trend for the previous period. So if there is an increasing trend, we will have a positive value. If the trend is decreasing, then we will have a negative. So just like alpha, beta is between 0 and 1. It reflects the weight most recent trend data. Alpha assigns weight to most recent demand data. Beta assigns weight to most recent trend data. It is either determined subjectively based on judgment, or we can use some software package like Excel to find the optimum value for beta. Now we will solve uh, the same problem. We will forecast using the same data set as we used for simple exponential smoothing using Excel. So if you recall, this is the formula for adjusted forecast. So we need the forecast using simple exponential smoothing, plus we have to add the trend factor. So I have already applied the formula for simple exponential smoothing using alpha 0.3. This column is showing that forecast. Now we need to find the trend value for each period and add these two values to find adjusted exponential smoothing forecast. So the formula for trend is here, you can see, as we discussed. So if we start with March, the trend will be equal to the value of beta. So we have taken beta equal to 0.3 as well. And in the next part of this lecture, we will learn to find the optimum values. So beta into forecast for this period, the period of March. So that will be equal to 487 minus forecast for the previous period, that is February, plus 1 minus beta into the previous trend. So we can either assign some arbitrary value for the trend, or recently we can take it equal to 0. So it's up to you whether you take some baseline trend value or start with a 0 value. So we can fix the cell for beta. So the trend value for March is 15, plus 15. And you can see that for some periods we are having negative values as well. Now we will simply add these two values. So this was the formula for adjusted forecast. So we have to add both values of exponential smoothing forecast and trend to find adjusted forecast. So that will be simply equal to this value plus trend. So here we assign the values arbitrarily. So we can use solver to find the optimum values. So we can apply solver function in this sheet, or we can let's suppose we apply the solver function in the same sheet. So just remember we had MAD of 201, so we should get a smaller value with the optimum solution. So using solver function, again, our objective function is to minimize MSE, mean squared error. Boolean variables are alpha and beta. And in constraints, we will set alpha to be less than or equal to 1. And alpha should be greater than or equal to 0. Similarly, beta should be less than or equal to 1. And beta should be greater than or equal to 0. Now, if we the alpha turns out to be 0.42 and beta turns out to be MAD was 201 with alpha 0.3 and beta 0.3. It reduces to 193, and you could compare the MSE and MAPE as well. So in this way, we can use adjusted exponential smoothing to incorporate the impact of increasing or decreasing trend. And again, I would encourage you to look at the values of tracking signal. In this case, again, we are although having some negative error in some periods, but the cumulative error as a whole is positive. So our tracking signal as a whole, in fact, for all periods is positive, and it is violating the upper limit of +3 in many cases. So again, we are under forecasting. There is a chance of stock out or back order. So we do need to be vigilant and take some action in advance. Thank you.